Hi students, in this video we're going to do an example where we solve a trig equation by using an inverse trig function. And this is a strategy that you'll need, especially when you have access to a calculator. So this strategy is most useful when we can't use a special triangle. So we can use a special triangle if we have that sine of x equals a half, or root 3 over 2, or root 2 over 2, and plus or minus any of those. Because we know that those are the values that sine takes for our special angles, like pi over 6, pi over 3, and pi over 4. We can also use a special triangle if we have that cosine equals plus or minus any of these values. And we can use a special triangle if we have that tan equals 1 square root of 3 or root 3 over 3 and plus or minus any of those. So these are all the values that we get for sine and cosine and tangent if our angle is pi over 3, pi over 6, pi over 4, or the reference angles associated with those, so the versions of those angles in other quadrants. But what if we had something like tan of x equals 0.7? Well, that's not any of these special values, and so I don't know what x is using a special triangle. I'm going to need to use an inverse trig function, and I'm going to need to use my calculator. So before we do the big example, let's do this baby example. If I take the inverse tangent of both sides of this equation, well, then I get that tan inverse of tan is just x because they're inverse functions. When I compose them, I get just x, and that's going to equal tan inverse of 0.7. And of course, now this is when my calculator comes in handy to give me the solution. As you remember from the section 4.7, if I take the inverse tangent of 0.7, I do that by looking for this blue value, which means I have to press second and then tan. And then I put in 0.7, and what do I get? 0.6107. We'll round that next decimal to a 3. Okay, so now let's use inverse trig functions in a more complicated example. Here we have secant squared minus 2 tan x equals 4. We know from the other videos that oftentimes we want to factor. Sometimes it helps to have just a single trig function in order to do that. And when I see secant squared, what's ringing in my head is the Pythagorean identity, that secant squared is equal to 1 plus tangent squared x. And so I replaced the secant squared with that term. Everything else stays the same. So here I use the Pythagorean identity. Now I'll be able to factor this because I have an equation of quadratic type. So I have just a single trig function and it's squared, and I've got one that's not squared, and I've got some constant terms. So if I'm going to factor it, I'm going to want to bring that 4 over. So I'll get 1 minus 4, which is negative 3, set it equal to 0. If I'm factoring, I always want to have it equal to 0. Now to factor this, I just sort of pretend the tan is my variable, and I will put a tan x here and a tan x here, because the first two have to multiply to tan squared. The second two have to multiply to negative 3 and add to negative 2. And so I've got to have negative 3 on one and 1 on the other. So now this tells me two things. It tells me that tan x minus 3 equals 0, or tan x plus 1 equals 0. In the first case, I have tan x equals 3. And in the second, I have tan x equals -1. Now, on this side, I can see that, oops, let me block my face so you can read everything. If tan x equals -1, well, -1 is the value of one of my special angles. Tan is 1 if I have pi over 4. So since tan of pi over 4 equals 1, well, then tan is -1 if I'm in quadrant 2 or quadrant 4. So tan is -1 if x equals the version of pi over 4 in quadrant 2, which is 3 pi over 4, or the version of pi over 4 in quadrant 4, which is 7 pi over 4. And to get the general solution of this, well, the period of tan is pi, so I can just put 3 pi over 4 plus pi, and that times k, and that encompasses this one as well, because 3 pi over 4 times 1k is 7 pi over 4. So that should be enough. But on this side, tan of x equals 3, well, that's not any of my special values, and so I need to take inverse tangent of both sides of this equation in order to break into the x. So it's kind of like what you did when we used logs and exponents. If I had ln of x, in order to break in there, I had to use an exponent. In order to break open this tan, I have to use an inverse tan. So what is tan inverse of 3? Well, I press second tan and 3, and what I get is 1.249. And if I want to look for the general solution, I just add on multiples of pi to that, so k times pi. So there you have it. Those are two examples of using inverse trig functions in order to solve equations. This was a relatively easy example. This was a more complex one. I hope that this is useful, and we'll practice it in class. See you soon.